Welcome to the day 2 of the Advent of Code. So the day 2 is called Red-Nosed Reports. So let's check out the storyline first. So fortunately the first location the historians want to search isn't a long walk from the chief historian's office. While the red-nosed reindeer nuclear fusion fission plant appears to contain no sign of the chief historian, the engineers there run up to you as soon as they see you. Apparently, they still talk about the time Rudolph was saved through molecular synthesis from a single electron. They're quick to add that since you are already there, I really appreciate your help analyzing some unusual data from the red-nosed reactor. You turn to check if the historians are waiting for you, but they seem to have already divided into groups that are currently searching every corner of the facility. So you offer to help with unusual data. So the unusual data is your puzzle input that consists of many reports. It's one report per line, and each report is a list of numbers called levels that are separated by spaces. So, for instance, here in the example data we can see that every line here is a report. Every column in each line is a level. So the engineers, they want you to deem which reports are safe. So the red-nosed reactor's safe system can tolerate levels that are either gradually increasing or gradually decreasing. So that means that the levels should be all increasing or all decreasing, and any two adjacent levels can only differ by at least one, but at most at 3. So that an example here we can see that this is safe, this is not safe, there's too wide a gap between 2 and 7, and so forth. So in this example data we only have 2 reports that are safe. So let's dive into the code. So first we parse the report data. What I want to do is read the file. Then I want to parse out all the integers in that. And I want to make that into a list. Now we have a list of integers, which is what we want. Then we will have a method that will check these safe rules for each of these report lists. So let's create that. This method is going to be called isSafe. We will take in a list of int, which we call levels, and this method will ultimately return if it's either is increasing or decreasing. We keep 2 Boolean variables to keep track of that. So it's increasing, we'll set them to true. And we will ultimately return those either if it's decreasing or if it's increasing. So we will loop through it. So we loop starting by 1, and the levels count up until levels count. So why we started 1 is actually was because when we want to compare it backwards, we want to compare the previous item so that we don't have to check for the overflow, the out of bounds problem. So we will skip that. So first we will check the first rule if the difference between each levels are in an acceptable range. So we will do a diff so we will check level, we will check the current level minus the previous level. That is our diff. So if the diff is less than 1 or the diff is greater than 3, oh sorry, yeah, then we will return false. So then it's unsafe. So we don't need to check any further. If it passes the diff check, we will check if it's actually if it actually is increasing or decreasing. So if the current level is greater than the previous level, it is not decreasing. And the opposite if the current level is less than the previous level. Yeah, forgot that. So is increasing is false. Yeah, so that is basically it. Yeah. So to find out which are safe, we will just run a link statement over that method. So we will have a say num-safe equals report. Oh, this should actually be called reports, I think. So reports count safe. So that is part 1. Just to check it. Oh, sorry. Wrong project. Yeah, this one was, so it's 2 like the example. Sorry there, I was just switching between my different projects. So we should get a 2 with this example data. That's what we got. My for my puzzle input was the real data was 220. So let's move on to part 2 then. So here the engineers are surprised by the low number of safe reports until they realize that they forgot to tell you about the problem dampener. The problem dampener is a reactor-mounted module that lets the reactor's safety system tolerate a single bad level in what would otherwise be a safe report. It's like the bad level never happened. Now the same rule applies before, except if removing a single level from the non-safe report would make it safe. The report instead counts as safe. So what we need to do is we need to actually check check to see if we remove one item, would that report be safe or not. So that's basically it. So if we go back to the code, so in this case we will create another method which can become safe by removing one level. And levels. So like this. So if we loop through these levels, we will create a new levels list by removing the current item from that list and then checking if it's safe. So we will check the level where the index is not equal to the current index in the loop, and we will make that to a list. And then we will check is safe new levels. And if it is safe, we simply return true. So that is basically what we need to do to fix this. We will just do num-safe equals reports count so we should check is safe by itself or can become safe by removing one level. And safe. So if we run this now, we have 2 for part 1 and 4 for part 2. So that's basically it. And if you want to check out this code, you can find it on my GitHub, which I've linked below this video. And I will see you in the next day, which will be tomorrow then. So hope you liked the video. Hope you subscribe to the channel. Hope you comment if you like it, or if you don't like it, comment anyway. I'm glad to hear all the feedback. Okay, so see you tomorrow. Bye.